Hello, I'm Tom Reader, and in this video I'm going to explore the difference between effect size and statistical significance. We're going to look at how to interpret the results of a study designed to test an interesting hypothesis. You've collected some data, run a suitable statistical test, and now you want to tell the world what you found. It's all about the p-value, right? That tells us if the effect we're looking for is significant. It tells us whether or not to reject the null hypothesis. So tell the world your p-value and your work's done. Well, it's not quite that simple. I can't really imagine what it would be like to be bald, but for your benefit, in this video, I'm going to make that huge mental leap. Let's just imagine that I'm bald and I'm looking for a cure. I have to the side of me two potential miracle cures for baldness. Here's the first one, Furball Express, get hairy fast, scientifically proven to give you back your luscious locks. It looks great. And the second one, Toupee away, say goodbye to wigs and hairpieces, say hello to hirsute happiness. Clinical trials show a miraculous improvement in hair growth. Wow, that looks pretty fantastic too. But I'm no sucker. I know not to trust the marketing spiel. I want to see hard evidence, data from an experiment before I believe the hype. So let's read the fine print. You know, there's normally an asterisk next to any claim about a treatment that is proven to have the desired effect, referring you to some evidence buried somewhere in a scientific report. Let's imagine we manage to get our hands on the reports for these two miracle cures. For Furball Express, the report looks promising. The headline says, volunteers treated with Furball Express were on average 50% hairier than a control group after just 2 weeks. For Toupee away, the report says, a clinical trial with 1,000 balding volunteers showed a statistically significant increase in hair growth after 6 months treatment with Toupee away. These both sound quite compelling, but which is better? The report for Furball Express suggests I'm going to see a huge increase in hair growth in just 2 weeks. But when I read on, I find that it says, we chose 4 people at random from a group of 8 balding male volunteers for daily treatment with Furball Express for 2 weeks. A control group of 4 men received daily treatment with an equivalent lotion but lacking the active ingredient. At the end of the trial, we measured the length of the hair of each volunteer at a random point on the head in centimetres using a ruler. Now that actually sounds a bit rubbish really. They've only got 4 people in each group, and the measurements are going to vary hugely depending on where on the head they selected to measure. And a ruler doesn't seem like a very precise tool for measuring hair growth. And they didn't even measure the length of the hair of the men before the trial started, so all the variation that they see at the end, well, that could just be caused by random differences between individuals in how hairy they were to start with. Crucially, there's no statistical test here. We need to calculate the probability that the difference they've observed, 50% longer hair in the treatment group, might have arisen just by chance. It sounds like a big effect, but if we've got no p-value to evaluate the likelihood that it could just be coincidence, are we sure it's real? Okay, so what about Toupee away? Here's what the report says. Half of the 1,000 volunteers were randomly selected for daily treatment with Toupee away for 6 months, while the other half received daily treatment with a control substance. 10 hairs were taken at random from the crown of the head before and after treatment and measured under a microscope to the nearest micron. The increase in average hair length for volunteers given Toupee away was 5 microns greater than in the control group. A t-test showed that this difference was statistically significant. P is less than 0.01. Now that sounds more convincing, doesn't it? They've got a nice big sample size, they've taken really careful measurements before and after treatment, and then they've done a statistical test which gives a clear conclusion. The probability of seeing these results by chance is tiny, less than 1 in 100. So Toupee away significantly improves hair growth. But hang on a minute, and this is a big but. Hair growth only improved by an average of 5 microns in 6 months. That's 5/1000ths of a millimetre. That's a very small effect, even if it is significant. At that rate, if I was bald, and frankly I do find it a bit hard to imagine what that must be like, I'd have to use Toupee away for 200 years for my hair to be just 1 millimetre longer than it would have been if I didn't bother. So I think that the correct conclusion here would be to steer clear of these two miracle cures altogether. We have no idea whether the supposed benefits of Furball Express are real, and we have really good data showing that Toupee away doesn't improve hair growth meaningfully. These examples show that to make sense of a scientific study which seeks to test a hypothesis, a p-value is not enough. A p-value tells you whether there is a significant effect, but it doesn't tell you how large or important that effect is. A large, powerful study can detect really small effects. A significant effect which is small might be really important. A 2% reduction in deaths from malaria would save thousands of lives around the world, but it might be essentially irrelevant, as it would be in the case of Toupee away. So, if you're reporting the results of a study, what should you do? Well, you need a proper test of your hypothesis, and you need to report the p-value. But you also need to describe the size of any effect you've detected. You can do this in various ways. For a difference between two groups, you might express the difference between the means as a percentage or proportion of the control or reference group mean. For a linear relationship between two continuous variables, x and y, you might use something called r², which tells you what proportion of the variation in the dependent variable y that is explained by variation in the independent variable x. Either way, it's your job to make sure that the world understands what your results can and cannot say about the effect you're interested in.